Okay, so we're going to do a quick run through graphical user interfaces, or GUIs, and event-driven programs. So, standard packages that you want to use for GUIs are in the java.awt and javax.swing packages. And most of the time when you build a GUI, you'll end up importing from those. So, difference between the two: Java library is considered essential Java, basically stuff that's been established as part of the standard Java language. JavaX is also standard but also extended, so in a sense not really part of what's sometimes considered core Java. And of course these designations change over time, so what will often happen is something that was in the JavaX package in one version will be migrated into the regular Java package after it becomes established. Okay, so basic idea with Java GUIs: there's two kinds of objects. Number one, there's a top-level container. That's the application frame. So think of that as the class for the application window. That can contain components, and it can run as a visible application. The other kind of object is a component. Components are things that get stacked onto the application window. So all those together are combined in what's called a containment hierarchy. So if you represent all the trees of all the objects in the application window, basically every object has to be added to or contained in another. Another key point: no object can be duplicated in the hierarchy, although one could be relocated. So you can move them around, but basically even if two objects are exactly the same kind of thing, they can't be the same object residing at the same point in memory. The hierarchy will turn that down. And in general, because you're stacking components on top of other ones in these application windows, only the last thing you add is visible. So that's all kind of abstract, so let's go ahead and start with the top-level container. JFrame is your basic application window, so again, your top-level container. And it contains all the things you'd expect in an application window. It has a title bar, just like, say, this one in PowerPoint up here. It has minimize, maximize, and close buttons. It has a content pane. So this area here in the middle, where I can add things, that's what's called the content pane. So we'll go ahead and make one of those. We'll call it LFrame. Put it in here. Okay. I'll call it DemoFrame. And we'll give it a main method because we can run it because it's an application. All right, so DemoFrame extends JFrame. Okay, so with JFrame, first of all, we have to import these packages. So let's import, if this thing ever gets going here. There we go. From javax.swing. And we'll also import java.awt. Java.awt. Okay, that has things like background colors and such. And import java.awt.swing, event. That's what we use for our event handling later on. Okay, so with all these in place, we can make a very simple frame. So let's make a constructor method. We'll call it DemoFrame. And we'll do the basic stuff. We'll build it. So the first things you typically want to do when designing a frame: number one, give it a size. So we can say, for this particular object, set size, and give it a coordinate pair. This method, set size, gets inherited from JFrame. So let's say here, set size in pixels and width and height. Okay. And the second one, if we want to, we can set the title. So for the title, again, inherited from JFrame, let's say, call it DemoFrame. And then that word will appear at the top when I create the frame. We're going to do one more thing. We're going to set the default close operation to exit on close. Okay, what that means is when I close the application window, then the application itself will stop running. So set default close operation, just say exit on close. And that's a constant that's built into the class. So if I hover over it, I can see it's from JFrame right there. Okay. And the last thing we got to do, make the window visible. Okay, so set visible true. If you don't do that, your application won't be visible right away. So the logic behind this, essentially, building your application window could be arbitrarily complex, could involve a lot of graphics, And if every step you're doing is visible, then it's going to be flickery, plus it's going to be slow because the program's going to have to, keep changing everything. So instead, the default way to build an application window is you add all the components to it. Then once you're done, the last thing you do is call setVisible to make it appear. If we run this now, let's make a DemoFrame object. Okay. And it'll just appear. That's all we have to do. Boom. Give it a second. There it is. There's our little demo frame. So this part here in the middle, that's our content pane. That's the place where we can add other components. But right now we have the title bar, and we have the minimize and maximize and exit button. And we're done. Okay. So moving on. Key methods. Some of which we've already covered: set default, close operation, set title, set size, set visible, we just discussed. These other three are about setting sizes. So setting preferred size, minimum size, maximum size. Usually it's pretty obedient with those. So for example, I can do set minimum and maximum sizes. And sometimes they're obeyed and sometimes they aren't, as you'll see. So let's do set minimum size, and we'll do, we have to send along a dimension object. A dimension object just has basically a pair of numbers. So our new dimension will be what size? So minimum, let's say 200 by 200, and we'll do a set maximum size with, 1200 by 800. We'll see how that goes. I don't know what happened there. Okay, so let's run it. We'll see how obedient it is. So if we try to shrink it down, yeah, I can't go less than that 200 by 200, so that's good. But yeah, it seems pretty clear that I can do an arbitrarily large size. So you can see, even though you can say, well, yeah, I want this to be a maximum size, Java doesn't always listen. And the truth is, there's a lot of complex prioritization schemes built into Java to basically say, under what conditions a minimum size is observed and under what conditions a maximum size is observed. Don't worry too much about it. Mostly the maximum size is for J components. Oh, wait, I had him set to 8200. That's a problem. Let's try that again. See if maybe that works better. But see, this is 800 pixels wide already, and I can go way wider than that. I can go way, smaller too. Anyway. All right, so it doesn't always listen. It has these size methods, but it doesn't always listen. Okay. So JComponent, then, we're getting into the components that we can add to the application window. JComponent is an abstract superclass for graphical components to be added to GUIs. So because it's abstract, that means we can't actually create JComponents. But there are many, many subclasses of JComponent. For example, for panels or menu bars, labels, pop-ups, all those we can do. And all J components are designed as containers. Containers is one of the superclasses of J components. Means that they have an inherent structure built in where they can hold other objects. So we're going to cover the basic ones. There are many, many, many others for specialized purposes, but only so many hours in a day. So first one, JPanel. JPanel is basically a borderless window. And typically it's a base area for adding graphics, custom graphics, or other J components. So a typical way it gets used, initially if you have a J frame, you want to add a J panel to the J frame so that then you can add other components onto the J panel or draw on it. Generally you can't draw directly onto a J frame. So you can do this. First we'll give it a new data member. So J panel JP. Okay, and then here we'll say start adding components. Okay, so we'll say JP. We'll actually create it here. JP equals new JPanel, and then add JP. So we're going to add it to the J frame, and we'll set JP's background color. JP.set background, and we'll say color dot, yellow. Okay, let's see how that goes. So we run this. Oh, how about that? We made the J panel, it fills up the whole zone, and we've made it yellow. So there you go. And we can add things onto that, which we will shortly. Okay, so every JFrame contains a container object called its content pane. If you want to get that, you can call the content pane method for that JFrame, for that frame container, and then use that as the object that you're going to add components to. So down here I have some sample code. For example, if I have a JFrame JF, I have a JPanel JP, I can call container, right? Container CP, I can say that's going to point to the JFrame's content pane, and then I can add the JPanel directly to the content pane. Well, 10 years ago, this is basically what you had to do, but since then, they've revised Java to allow you to add components directly onto the JFrame. But if you see some old code that talks about content pane, yeah, that's what they're doing. Okay, next one is JLabel. So JLabel allows you to add static text or images to a J component. So it could be just plain text, or it could be images from some kind of folder relationship, either in a local directory or some complete path to it. So basic syntax, well, for one, if we have a JPanel, let's do two JLabels here. We'll add them, JLabel JL1, JL2. Okay, so we'll add them to this JPanel. So JL1 equals new JLabel. If you want to make it with text, you can just put some text in. I could say something like, this is a JLabel. Okay, if I want to do an image, it's a little more complicated. So essentially, I have to first create an image icon, and then I have to point the JLabel to it. So we'll paste this in here in a second. I need to fix that quotation. Okay. So this one, essentially what I'm doing, first of all, I create the image icon and I reference a particular image. Now if I go through my folder path, I know I have one here. So I go up to desktop and I go up a couple steps. Go into my workspace. And here in fall 2019, I have this sunnyday.png. So if I reference that and just do here sunnyday.png, because it's in the same folder, right? This is where it needs to be. Okay, it's in my fall 2019 folder that I'm working on now. Okay, and then this question mark is just about other options that I'm just using defaults. I can actually leave that off. Okay, and then here I set JL2 to be a new label based on this icon, and then I add it to the JPanel. So if I run this, ta-da, I've made my text. Now there, I didn't add my first one. jp.add JL1. Okay, I'll show the text. So there we go. This is a JLabel, and here's my sunny day image. Hooray. Now, the thing about JLabels, they're generally static content, although you can change them. Okay, next one, JMenuBar, JMenu, and JMenuItem. These are the drop-down menus for your GUI. So just like here, I can click on tabs, and there's things down below. Standard Java frame classes, they provide the same function. So menu bar, that's this bar. JMenu, those are the individual tabs. So a JMenu object is one of these tabs like File or Home or Insert. And JMenu items are the options underneath. Okay, now, funny thing about JFrames, you don't just add it the same way as you do a different component. There's already a place for a JMenu bar in a JFrame. So we can do that. First of all, let's create a couple objects. JMenuBar JMB and JMenu JM1, JM2, and then we can create some JMenu item, JM1, JMI1A, JMI1B, JMI2A, JMI2B. Okay, so there we have all of our objects. Now we're going to add them right here. And related objects. Okay, so when you're adding a menu bar, you don't just add it. What you do is set JMenuBar, okay, because there's a place for it. So set JMenuBar JMB, and I should say JMB equals new JMenuBar. I have a new one. And then instead of adding it again, I set this JMenuBar to point to it. Now for the others, JM1 equals new JMenu, and I can give it the option, say option 1. That's kind of lame. We'll do one for file and then one for format options. So JM1 is this, JMB add JM1. Okay, so I add that component to JMB. Likewise, JM2, we give that a new menu, and I'll call this, I don't know, style. JMB, JM2. Okay, so if I run this, I'm going to see the menu bar, and I'm going to see that I have two tabs on it, File and Style, but they don't actually do anything yet. So there's File, I can press it, Style, I can press, but they don't actually do anything yet. Okay, so if I want them to sort of do something, I can make the options underneath. So I can do JMI1A, new JMenu item, okay, two file options, let's have load, and JMI1A. Okay, and I'll do a similar one here for save, with just 1B. Okay, and I'm going to do a similar pair for style. So set those to 2A and 2B. So one will have color, and one will have black and white. I don't know. I don't have good options. I don't have anything else on my mind at the moment. Okay, so if I run this, now when I click on the menu tabs, I'll see some options. Oop, what did I miss? Oh, JM2. Oop. Okay, so when I run this, now if I click on it, I see the two options, color, black and white, or file, I see load and save. If I wanted to, I could set stuff to happen when those get pressed, but I don't have that now. Okay, so moving on. A text field. Text field is a simple single line text field. If I want to read what's in it, I call the get text method for it. If I want to assign it a particular text, I call the set text method. You also have the option to modify it to make it editable or not by calling the set editable method and sending along either a true or false. Okay, now sizing JText fields, it's possible, but it's a little tricky since Java considers a lot of factors in trying to set up what the correct size would be. Things like how big the window is, what font you're using, things like that. So it's a little tricky. Often the best way is to just, pick a size and see how it looks. So I'm going to add JText field, and in just a moment I'm going to add a JTextArea. Okay, so JText field, again, is a single line of text. Okay, so I'm going to say JTF equals new JText field. I'll give it an initial size of 10, which is actually pretty big for this. And then we're going to add it. Okay, and you can see what it looks like. It looks just like a little text box. And if I want to, I can add some stuff into it. Okay. Now a JTextArea, on the other hand, that is multi-line text. So, and it has all the same features as JText field. So you can set text, you can get text, you can set editable. If I want to add some text in addition to what's already there, I can call an append method. And if it's big enough that I have to worry about scrolling, you can even add scroll bars to it. It's not that difficult. There's a little snippet of code here from Stack Overflow you can check out if you want. So, but we'll do this. We'll keep it simple. We're going to add JTextArea. Call it JTA. Down here, we're going to say JTA equals new JTextArea. And we're going to give it some initial text. So we're going to say jta.set text. And we'll say, we'll give it a few lines. So we'll say A, \n for a new line, B, \n for a new line, \n rather, C, \n D, \n E, \n F. So we'll give it a few lines there. So we're setting its text to have A, B, C, D, E, F, all on separate lines. And then JP, add JTA. So we'll add it to that base panel. Ta-da! There it is. Now one thing you may notice it doesn't look that good because it just keeps adding things left to right. Well, it only does that while there's space. Once it starts running out of space, it might reconfigure how things are set up. Interesting. Okay, so you see it'll show what it can left to right. Okay. Last one of our components is a JButton. JButton is a clickable object the programmer can specify instructions. If you want to call its constructor with a method, then you can assign a text label to it. So let's do that. I'll make a couple buttons, and then that'll be our intro to all these basic components. Okay, so I'm going to add on the JButtons here. That'll be the last thing. JB1 equals new JButton, and I'll call it button number 1, and I'll add it. And JB2, new JButton, button number 2 as a label, and I'll add that one as well. Okay. So here I have button number 1, button number 2, and again, if I scrunch the window a little bit, you know, it'll realign them. Okay. Ta-da. Now, colors. In Java, your standard 24-bit RGB colors, RGB for red, green, blue, they're provided through the java.awt.color class. There's basically two ways to designate colors. One is with constants. So constants are typically the name of the color in capitals or lowercase, and there's a whole lot of them in there. There's red, there's black, there's blue, there's yellow, some oddball ones. Strangely, there's not purple. Purple is not one of the constants, so that one's not in there. Many others are, even odd ones like magenta. Or you can create them through numbers. So one possibility is that you assign the 3 red, green, blue values separately. So each of those are luminance values, and we know if we mix all the colors together, we end up with white. If they're all at peak luminance, 255, then these 3 together, right, this new color, 255 for red, 255 for green, 255 for blue, that turns out to be white. Or we can send it all as one big number. We don't have to send them individually. We can multiply red by 256 twice and the green value by 256 and then the blue value. That way, essentially, we have a 24-bit number. The blue value is the lowest 8 bits, the green is the middle 8 bits, and the red is the highest 8 bits. So in each of those 8 bits, a number from 0 to 255. So we're going to do a quick example with that. Let's cover, say, let's do our background color. Okay, I can do one with the buttons. So let's do that. JB1.set background. We'll say new color, and we'll do 3 zeros. So that together is black, right? 0 luminance. Whereas if we do it with the other JButton, we can max them out to 255. And they'll be white. And if we pick the number in the middle, 128, then they'd be gray. So we do that. Ta-da, this one, why isn't he looking? Well, that's strange. Something weird's going on there. Let's see. Let's try this. The button's not really obeying. That's strange. What's going on with you, button? Oh, because I added it. That's why. Because I added it after I added it to the panel. I have to set the color. Let's see, that should work then. Okay. Oh, something strange here. Oh, JB1, that's why, because I overrode the background color. Haha. Okay. There we go. Now that first one is black, the second one is white. That makes sense. Okay. So let's make this one, make it a light gray. Or this one is kind of a darker gray, actually. So it's a little too dark to even still see. All right, we'll dial it up a bit. Let's see what happens. Okay, at least I can read the text there. Okay, so that's how colors work. So red, green, blue. And if I wanted to mix them together, for example, I could combine red and blue to make purple. Ta-da! There you go. Okay. Now, next thing, stacking GUI components. So by default, visibility works the same as stacking pictures onto the JFrame, which means the last component you add blocks any prior ones. For example, in most cases, if you add a whole bunch of J panels, only the last one that you add will actually be visible. So in order to display components on the same GUI in some sort of sensible layout, we use what are called layout managers. For that, basically what layout managers are used for: number one, dividing the object, the surface, into sub-areas. It also helps automate, standardize the adding sequence. So we don't have to worry about exact pixels or how everything's going to look. We know that Java is going to handle the layout regardless of what the screen size is. So there's a whole bunch of different layout managers. Basic ones: box layout, flow layout, grid layout. It is possible to set them with just pixel numbers, but usually you don't want to do that because of variation in screen size and application window size. So the box layout we'll cover, but don't worry too much about that one. I'm not going to ask you about it on the exam. The two we'll talk about are flow layout and grid layout. So flow layout is what we see in our initial default location. For most of these components, it's the default layout. Basically, as long as there's space available left to right, it'll show them all. So think of this as being same as centered text in Microsoft Word. As long as there's room on that top line to show everything, it'll show it. Once it starts to run out of room, it'll start pushing things off to the next line. Okay, that's your flow layout. So it centers it and it starts adding components left to right. And once you run out of room on one line, it'll make a new horizontal line to add things. Grid layout basically divides your window area into a group of same size rectangles, or grid cells. And when you call the grid layout manager, you send along the number of rows and the number of columns. Get rid of that. So basic way to do flow layout, let's do the syntax. If I do that, what you do for the component, you call set layout, and you say the kind of layout you want. Well, with a new flow layout, you just say give it a flow layout, and you don't have to worry about that beyond. There's no other details to provide. With grid layout, you call set layout, and you say, I want a new grid layout. Then you have to specify how many rows and how many columns. So you're calling grid layouts constructor. Okay, so if I wanted to do this, for example, for JP, I could do this right here. I could say jp.set layout new grid layout, and I don't know, let's say 3 rows, 3 columns. Let's see what happens. All right, so funny thing, okay, with the grid layout, it's only ever going to make as many columns as you need. It's going to make, even if you give more rows than you need, so I have 6 rows here. If I say I want 7 rows, it'll give me those 7 rows. It just won't fill up the one with anything new. This yellow here is from the background of the original J panel up there. So kind of a strange thing. But that's the way it does it. So I'll leave it as 3, 2. Now, the other thing you'll notice with the grid layout, with the buttons become absurdly large because they fill up the entire grid cell. So if you think, hey, that looks kind of crazy, I would agree that it does, I might say add a new J panel on top of that. So I might say, instead of saying JP, add JP1, I might do JP J panel JPB1 equals new J panel. Okay, and then then add that new panel to it, and then add the J button to that new panel. Okay, so that's what I've done here. I've said add a new panel to JP instead of the button. And then the button will be normal small size. The panel will fill up that entire grid cell. So if I run this one, the first J button, it'll look normal. The second one still looks kind of screwy. I can do the same thing there. Okay, so JPB2, JP, add it there to the second panel, add it there. There we have it. Okay, I don't need you anymore. Okay, so if I run this now, both the buttons will be same normal size. Whoa, it didn't like that. What happened there? Oh, I have to have the second J button. I had the wrong button. Okay, there we go. Ta-da! No, that's fine. If I want to, I could set a better background color for those too. You could do JPB1 set background. I'll do color.blue. That's fine. And then for this one, I'll do color.jpb2 set background color.green. Okay. And then when I run that, ta-da, then I have different colors there. Okay. So that's pretty much it for GUIs. So I'm going to pause this one, and then I'm going to come back in just a moment and talk about listener interfaces.